The subject of our discussion is word cloud in R for PDF eBook on ACM. Learn word cloud and word association easily. Let's start our discussion on word cloud generation for a PDF eBook. Now it is a step-by-step approach to word cloud of PDF eBook. The eBook considered for analysis is Supply Chain Management by Dr. A. Rajagopal. Step 1. Load NLP, TM text mining, R Color Brewer, Snowball C, Word Cloud, PDF tools, and StringR libraries. Step 2. Input the PDF book as text using PDF tools package. Step 3. Clean the text data. Step 4. Make corpus and DTM document term matrix of the cleaned text data. Step 5. Visualize the text data and generate word cloud. Step 6. Find word associations with correlations. Now let us pause these comments and load the libraries required for running the analysis. Now let us input the SEM ebook. Let's input the data. Now let us create a vector ABC for capturing the text data using nested for loop. This for loop saves the documents which have been read into the data object txt. Now let's run the for loop and store the read-in text data as matrix in ABC object. Let's display the head and tail of ABC. The tail of ABC also is displayed. Now let us run stringr functions for removing the symbols which we don't want in the word cloud. Now we'll make use of text mining TM functions for removing numbers, removing punctuations, then bringing the text to lowercase, since our platform differentiates between uppercase alphabets and lowercase alphabets. Now let us remove the words which we do not want to appear in the word cloud. Specific words are removed. Now let us form the stop words. The standard English stop words plus the and. They are defined as stop words, and remove words is made use of for removing the stop words. Now let us strip the white space, remove the white space that has been generated by the text cleaning activity. Now run the function word stem on ABC and then carry out stemming of the text data. Now let us assign ABC text, the cleaned text data, to review underscore text and display the head and tail of the cleaned text data. The cleaned text data head and tail is displayed. Now let us make a vector source of the review underscore text, and let us make a corpus of the review underscore source. Review source, let us make a corpus. Let's now inspect the document, first 10 documents of the corpus. The first 10 documents of the corpus is displayed here. Then now let us form document term matrix from the corpus. Run this function, command line. Now by giving a command DTM, we'll be displaying the metadata of the document term matrix. This metadata, it indicates that number of documents is 370 and the number of terms is 7070. So matrix of this size will be formed as DTM. Now let us inspect a portion of the DTM. A portion of the DTM is displayed here. For example, the term for performance appears in document 204 once. Planning, the term planning appears twice in document 202, and practices appears in 204 once. Similarly, we can inspect and analyze the frequencies and the occurrence of the other words also, other terms in the total document term matrix. Now let us save the document term matrix as matrix in DTM2 and make a column sums. Column sums for will give the frequency for the, for example, this column sum will give, first column sum will give the frequencies for the performance, word term performance. Similarly, the second column sum of these values will give the frequency for the term planning, etc. So similarly, we will be able to find out what is the frequency by getting the column sums of DTM2. Let's run this. Then sort the frequency in the decreasing equal to true, the decreasing order, the descending order, so that the high frequency words will occur at the top and subsequently the lower frequency words will occur in the matrix frequency. Now let us run this sort function. Display the head of frequency, the top 20 words. These are the top 20 words: supply chain, etc., cost, logistics. These are the high frequency words, the first 20 words. Now let us remove this particular symbol which is occurring in the 13th position. Let's remove this symbol 13. Let's run this, remove the symbol, then assign the names of the frequency matrix to words. And now let us visualize the word cloud with words and frequencies. So based on the frequencies, the word size will vary, and the high frequency words will appear in larger text font size, and smaller, higher, lower frequency words will appear in smaller sizes. Maximum words, let's make it 90, and random order equal to false. This will ensure the high frequency words appearing in larger font size and lower frequency words terms will appear with lesser font size. So that is the function of the random order equal to false argument. Rotation percentage equal to 0.4 will ensure 40% of the text appearing in the vertical direction. And colors equal to Brewer Pal 3 dark 2 indicates the color palette that's to be used for the word cloud display. And scale equal to concatenated values 3 and 0.5 indicates the range of the font sizes, the text that is going to be displayed in the word cloud, with maximum font sizes 3 and minimum font size 0.5. Now let us run this word cloud function, visualize the text data. Word cloud is getting generated nicely. It has been displayed. Now let us make a bar plot of the high frequency words using this bar plot function. Let's run this and make a bar plot of the top 20 words, the frequency of the top 20 words being displayed. Now let us make use of find associations function over the object DTM, document term matrix, for the terms chain, cost, logistics, material with a correlation limit of 0.5 and display the association results, word association results. Let's run this function. Processing is on. It's taking a while. The result has been displayed. Now there is a correlation of 0.97 between chain and supply chain. There is a high correlation. Cost and ordering 0.61, cost and carrying 0.61, cost and shortage 0.6, cost and unit 0.59, cost and BOM 0.52, etc. Logistics, there is no correlation with any other board, and material and handling, a correlation of 0.58, material and movement 0.56, Similarly, the other words also, the correlation is displayed. So this word association function results gives us an insight into the theme on which the ebook has been written, and the important concept that has been highlighted in the book is clearly brought out. That brings us to the end of our discussion. Thank you. The author, Dr. A. Rajagopal, can be reached at arg1962@gmail.com.